All right, welcome to Ops lecture number 2, everyone. We've done the check-in poll successfully.
All right, so if you guys were here last week or a week and a half ago for our first lecture, you will remember that we went over voltage, current, resistance, some of the basics in building circuits, and we talked about Ohm's law. Today we're going to review Ohm's law because that's going to be very important for your first project. Then we're going to go into a bit about circuits and schematics, talk a little bit about what a node is, and then talk about some of the different components you'll find when building your circuits. All right, so just to review voltage, that's the voltage is a potential difference between 2 points. Voltage is what makes the charges move. It's what creates the current in the circuit. So charges want to move from high potential to low potential, and the higher voltage you'll have, the more current you'll create. Voltage is a relative measurement. So what that means is we always measure it relative to another point. So most of the time in circuits, we'll find a grounding point, which we'll consider a 0 voltage, measure the rest of the voltage around the circuit, compare it relative to that. All right, so your first little warm-up question is to try and find the current I. Remember your units. Remember Ohm's law to figure it out. And take your time when you know it. Someone can say it, or you guys can type it in the chat. Great. So, all right, so a lot of people got it. It's 3 milliamps. Some people just put 3, so be careful. As you can see, we're doing V divided by R, but R is 3,000 ohms. So that leads to a current of 3 milliamps, which is 10 to the minus 3. And then here's another one also using Ohm's law.
Okay.
All right, yeah, it looks like a lot more people are getting the correct units this time. It's going to be 5,000 ohms because we're dividing the 10 volts by 2 milliamps, which is 10 to the minus 3, which gives you 10 to the positive 3 on top, which leads to 5,000 ohms or 5.
All right, so now we'll be moving on to circuits and schematics. Looks like most of you are ready to get started with your math brain turned on. So a circuit is basically any complete path that allows current to flow. And a complete path is required for your current to do something useful. And there are many ways your circuit can go wrong, but one of the most common ways it goes wrong is when you short a component. And what shorting means is you're creating an unintended connection between a component and between 2 different voltage levels. So for example, on the lower right hand corner, we have a battery that's just like connected across its terminal, and that we say we've shorted the battery. And the thing about shorting is if there's no resistance between the 2 different voltage levels, that theoretically leads to unlimited current, and that could result in bad things. For example, if you short your battery, it just will not be pretty. Don't do it. Okay, another way your circuit can go wrong is when you have an open circuit. And an open circuit is an unintended disconnection in the path. So if you have a disconnection in your path, basically your current will not be able to flow in a complete path anymore. So your electricity will not do anything useful anymore. So will the LED light up in this circuit? Just feel free to type the chat. Spam the chat. Yes or no? Obviously not, because you have a disconnection in your circuit. Okay. Right. And in terms of circuit components, we call everything in the circuit with circuit components, and we have active and passive components. Active components supply energy, so there'll be things like battery, voltage sources, current sources. On the other hand, passive components don't supply energy, but dissipate or store, release energy. Things like resistors, capacitors, LEDs are called passive. And in particular, wires are passive components with negligible resistance. So they cause a really small voltage drop across themselves. And for ideal wires, we treat them as having zero voltage, zero resistance, so which will be accurate enough for us. So wires have zero resistance across them. And a schematic is basically a diagram used to represent a circuit where the lines will be the wires and then components will be represented with symbols. If you are familiar with schematics, you'll be able to guess what these components are. The first thing is battery, where the longer line, or sometimes denoted with the plus sign, is the positive terminal of your battery. And this little thing is for ground. So wherever you see this is where you're measuring your voltage across relative to in different parts of the circuit. So we usually treat ground as zero for convenience. And these things represent resistors. This represents LED, switch, capacitors. Yep. Any questions so far? We've covered Ohm's law practice, open short circuit, active passive elements. Pretty straightforward things. Okay.
All right, now we're going to talk about nodes. We talked about a little bit before, but it is points in the circuit that have the same voltage potential across it. So in this diagram, you can see everywhere that's the same color has the same voltage, right? You could think about it as any 2 points that are connected by only a wire, because the wire should have no resistance. So it would be the same voltage at every point on the wire. And then across a component like a resistor, you should get to a different node. So as you can see, across every resistor, you jump to a different node. If you're traveling just along the wire, you stay on the same node. All right, first question, are these 2 yellow dots on the same node? All right, everyone's saying no because there's a resistor between it, which creates a change in voltage. All right, what about now? Yeah, so this one's a little bit trickier, but yes. So since it's connected by a wire, they will be the same node. What that essentially means is none of the current's going to travel across the resistor. It'll be like the resistor's not even there. The circuit will ignore it. And it's like this whole part's connected into one node.
Yeah, we usually say current travels through path of least resistance. So in this case, the resistor is just like not there. Yeah.
So looking at these 2 points, we know that they're the same node because they're just connected via wire. We also know that, what would the voltage drop be between these 2 points? Zero, I kind of gave it away. But yes, they're on the same node, so it's 0. Good job. Okay, this one I won't give away. So if we look at the red dot, what other colored dots will be in the same node? And then select all that apply. So we're looking at the red dot. Which ones are on the same node as the red dot?
I get to see like live results of this poll, so it's really interesting. Cool stuff. 30 more seconds to fill this out. So whenever you see a possible path with no component between the 2 points, the 2 points are on the same node. Right, it looks like most of you have voted. So I'll share the result.
All right, so yeah, it looks like only one person put purple, so you guys all did pretty good at knowing that's not on the same node. As it turns out, all the other points are on the same node because you can get to every other point by just crossing a wire. So you could go along the top to get to yellow and orange, go along the bottom to get to green and blue. So every color except purple are on the same node in the circuit. Any questions about nodes or anything we've covered? or about the problem at all?
It might be a little bit trickier to figure out why orange is on the same node as yet red, but you can see there is a path to travel to orange that has no resistors in between. So it's basically connected. Sounds like everyone's doing well. Yeah, okay. Now we'll move on to circuit components in real life. So we have a battery here. A battery, as I've said before, is an active component providing energy to the circuit. And it basically translates chemical energy into voltage potential between its two terminals. So for your project, you'll be using your Arduino to power the circuit just because the kit doesn't come with JST connector, but if you have one, feel free to use it. So what the Arduino does is once you connect the Arduino to the battery, it gets powered and it outputs 5 volts or 3.3 volts at the pins. And Arduino also has the ground pins. So basically, yeah, you just treat the Arduino as the battery and you'll be able to see more details about that on the spec. So resistors, are stuff with resistance, right? And they have different resistance values, and these resistance values are represented with color bands on the resistor. If you have seen this before, you might know already, but the first and second band, or the third band, if you have 5 bands, represent the value, and then the second to the last band represent the multiplier, and the last band represents tolerance. So see on the right-hand side, the chart represents what different colors will be as values or multipliers or tolerances. Last year, Jackie made a pretty cool mnemonic for memorizing these values, but you really don't have to memorize these values. There are tools online that will help you determine resistor values, but it's good to know how to calculate it. So let's get a practice of it. So what would be the value of this particular resistor? Remember, we have 5 bands here, so the first 3 bands would represent the value, the 4th band would represent the multiplier, and the 5th band would represent the tolerance. Feel free to type in your guesses as we go, but since we see that first band is brown, so that represents 1. Second band is black, that is for 0. Black, 0. Orange multiplies everything, so 100 by 1,000. And then brown gives us 1% tolerance. So most of you, some of you have got it right, so it'll be 10K ohms. Yeah. Right, and then LEDs are light emitting diodes. They light up when sufficient current is passed through their terminals, and the legs of the LEDs are called terminals. Too much current can burn out your LED, so you want to determine the right amount to pass through. For example, if you just connect your LED without a resistor, it will probably break, and you don't want to do that. All right, so the LED has 2 terminals. There's anode, plus the plus terminal and the minus terminal. It's kind of hard to determine by the length of the legs. So I usually go by the things inside. So the round edge would be the positive side, and the negative, the flatter edge will be, no, the round edge will be the positive side, and then flatter edge will be the negative side. And yes, very good question. If you see here, this is what we have for our sign convention, and writer will
Yes.
know more.
So when looking at the circuits, we have to kind of understand which way the current's flowing through the circuits. So we say whichever, we usually assume a way a current's going, and in a simple circuit like this, we assume that the current's flowing out of the positive end of the battery. And then we mark on their components the polarity of it. So the current flows into the positive side and exits the negative side. So with the resistor, we see the current's flowing in, positive, negative, and we say the voltage jump across it is going the opposite way because it's like you're losing voltage. So you would gain voltage if you went up the other way. And it's similar for the capacitor and inductor. Looking at this circuit diagram down here, you'll see something very similar when designing your circuit for the project. So we're not going to solve this one for you, but you can reference the circuit when trying to figure out which resistance you should use for the circuit in your project. All right. Now, a lot of you have breadboards in the kits you already got. So the breadboard is how we're going to make the circuit, what we're going to put it into that holds all our components together. What's important is to know how the nodes work on the circuit. So if you look in the top right, and any of the points that are connected with the same color line are on the same node. So on the left and right, we have these long vertical columns, and they're all on the same node. So if you connect a component to the top and bottom of the same column there, they'll be connected via wire almost. And then in the middle, we have horizontal nodes. So every row is on the same node. So if we look at these pictures in the bottom left and right, these horizontal rows are single nodes, and we could create a single node by connecting them via a wire, because the wire creates a single node between pieces. But if it weren't connected via wire, then they'd be different nodes.
Yeah. And note that the vertical line in the middle of the breadboard divides the two big columns of horizontal lines. So on the left side, they're connected horizontally, but on the right side, they're connected horizontally separately from the left side.
So basically, any point where you see like a color going through it, it's all like it's connected via a wire. So it's like there's wires connecting all these little holes in your breadboard. All right, so we had one question about which side you should read are. So a lot of the resistors you guys will be using will have only the 3 value bands in a single tolerance band. Tolerance band oftentimes is like gold or silver for most of the resistors we'll be using. So that's a good way to tell. But also the tolerance band is spaced out a bit, so you know to read it from a certain way. That being said, the resistor itself is symmetric, so there isn't a polarity to it. So it doesn't really matter which way you plug it in. You can flip it either way and it'll do the same thing in your circuit.
Yep. But do note
Any other questions?
Oh, sorry. Feel free to type in your questions in the chat because we are actually monitoring the chat if you haven't noticed. Yeah, but polarity does matter for LED while it doesn't for resistors. So be careful not to short your LED or to pass too much current through your LED or not pass enough current through your LED or mess up your polarity. Okay. So your project is basically creating an LED circuit. All you have to do is light up an LED, but in order to do that, you will have to calculate some things and apply what you learned throughout this lecture. So it'll be due this Friday at 6 p.m. Ryder will be in the lab. Actually, I will be in the lab too from Friday 5 to 6. So that is the last time you can get checked off for this project. And in order to get checked off, you have to show us your finished product, so the LED circuit in this case, and answer some of our questions. The best way to get checked off is to come to our officer hours and just like hop in the chat, be like, hi, can I get checked off for offs? But if we are not available, you should be able to reach us over Messenger, or you should be able to get checked off by any officer in the lab. Right, so as I said before, Discord officer hours is the best way to find us. So Ryder will be there at these hours. I will be there at these hours. As I've said before, don't be afraid to just hop in and be like, hey, I need to get checked off. They're all nice people. Right, and stay in touch with the Facebook group, as I said before, in order to get the most updated information on everything. And we've also linked our Facebook profiles here again, in case you need to find us, and feel free to use the Piazza for any questions. And for 2 of you who don't have your kits yet, you may use Tinkercad to complete this project. If you have any questions about Tinkercad, please feel free to contact me. I was going to do a demo, but it's only two of you, so I think I'll be able to help you out better individually if you need help. But basically, all you have to do is go to tinkercad.com, and it's the same thing as doing it on the breadboard, but like looks better. Okay, now I believe that is it for our lecture, which we're going to try to keep our lectures short and sweet if you haven't noticed, so that it doesn't take too much time out of your evening. And I have one final poll for today. Actually, I don't, I deleted it, but can someone tell me where you find the spec? Where would you find the spec? Okay, the slides link and everything links will be posted on Facebook right after the lecture. Actually, right after the YouTube processing finishes, I'll post the slides, spec inside the slides, and the YouTube video. And thank you, Margot, for posting the link. It's tinyurl.com/opslecture2. If you haven't noticed a pattern, it's tinyurl.com/opslecture_n, where n is the number of lectures we've done so far. I think this is available for most part. I haven't had problem creating links yet, but it might change in the future. But ops lecture n is a good starting place to just start guessing numbers and links.
And steal our links.
Yeah? You don't see our links?
No, I said they're gonna start stealing our links. They're gonna get it before we do.
You're right. I will make them not available. Don't worry. Actually, oh my gosh, don't search up lectures slides for lectures you haven't attended yet. Just don't. 1 to 2 are good. Don't attempt 3. All right. If you have any questions, feel free to ask us. That's all we have for you today. Remember to do your project by Friday, 6 p.m. And if you haven't filled out the reimbursement request form, do it by tonight. Just do it. Okay?
Please do it tonight, yeah.
Thank you all for coming out. You may stay longer if you want to socialize with us, but I will now stop the recording.